So today we'll be talking about polynomials. So these things right here, if you could have guessed. What are they? Well, polynomials are basically expressions with variables and constants. So some examples are like the number 4, or x plus 4, or x squared plus 3x plus 6, right? These are all different polynomials. And polynomials consist of different terms separated by a plus or a minus sign. So, for example, in x squared plus 3x plus 6, x squared and 3x and 6 are all different terms. Polynomials that have one term, like 7x or 12, are called monomials. Mono meaning one, and nomial meaning name, or in this case, term. Polynomials like, I don't know, x plus 5 are called binomials because they have two terms, right? And if you could have guessed, polynomials with three terms are called trinomials. And there's a few terms I want to get out of the way. So, variables, okay, what are they? I mean, you guys probably already know what variables are. They're basically just letters. So you could do x, y, z, right? Or they could be to an exponent, so, x squared, or, y cubed, or z to the fourth. Next term I want to get out of the way is coefficients. So what are coefficients? Well, if we look at the number the polynomial for x, which you guys learned, this special polynomial is called a monomial. If you look at it right here, you see it consists of two parts, so a 4 and an x. So the variable here is going to be x, and the coefficient is the constant or number that goes with the x. So a constant, like maybe 5 or negative 12, is just a number that's by itself without a variable. Sometimes you can also think of it as being next to, or at least being the coefficient of a variable to the 0th power, because we all know to the 0th power is 1. Anything to the 0th power is equal to 1. Like terms have the same variables and the same exponents. So for example, 2x and 3x are like terms, but 2x squared and 3x are not like term, because 2x is to the second power and 3x is only to the first power. And same thing with constants. So if we have maybe a 4 and a negative 7, these are like terms because their variables are both to the 0th power. Same variable and same exponent. So now that that's out of the way, I learned a little bit about something called the average rate of change. So you may recognize rate of change as something called a slope right up here. And the slope is basically here. If I just draw a graph right here, that's a bad graph. It's basically just the tilt or gradient of a line. So, but what does it mean average? What does it mean by average rate of change? Well, when you start to get with graphs with polynomials, because for example, like a line like this, that might be the equation y is equal to x, right? But once you get into more complicated polynomials, you might have something like y is equal to x squared plus 3x plus 7, okay? And that graph is going to look a little more wonky. It's going to have a lot more curves and bends. So it might look something like that. So obviously there's no straight lines in this graph, so it's going to be very hard to figure out the exact slope of every point. So what you might do is find the average rate of change. So they'll probably give you two points, and what you got to do is you got to mark them on the graph. So maybe here and here, okay? And what you have to do is you have to find the straight line that connects them. So pretend it's a straight line, okay? And what we're going to do is we're going to find the slope of the line that connects those 2 points. And that's the average rate of change. Just finding the slope of the line that connects the 2 points is going to be your average rate of change. Sometimes they may actually give you just the x value. So maybe they might say, okay, well, find the average rate of change between when x is equal to 4 and x is equal to 10. And then you just have to plug those numbers in to the formula and you'll get your points. Okay, so here I prepared a little graph equation right here. So we have y is equal to negative x squared plus 3. So if you've learned anything about parabolas or some of their properties, you know that when when the x squared is negative, it's going to be facing down, and because it's a plus 3 here, it's going to be starting at y equals 3. So what we have here is, let's just give an example. So we'll find x is equal to 0, and how about x is equal to 2, okay? So between there, okay? So what we gotta do is first, let's just plug 0 in, okay? So if we have negative 0 squared, we just know that that's going to be 0, right? So that was a bad y. We're going to be left with y is equal to 3, okay? Now let's solve it for for x is equal to 2. So we have negative 2 squared, and remember I should have had this before with parentheses. It's not negative 2 squared, it's the negative of 2 squared, or the opposite of 2 squared. So we're going to have the negative of 2 squared plus 3, and that's going to be equal to negative 4 plus 3, okay? And that simplifies to y is equal to negative 1, okay? So what do we know about slope? Slope is equal to the change of the y, change of rise, over the change in run. So I'm just writing, that's supposed to be a triangle. Delta means change, or you could also write it as y2 minus y1 divided by x2 minus x1. Well, let's start. So what's our y2? Our y2 right here is going to be negative 1, okay? So we have negative 1 minus, well, what's our y1? It's 3, right? So we're going to have negative 1 minus 3, or plus negative 3, okay? And it's divided by, well, what's our x2? Well, 2, right? That's our second number we said. Minus, what's our x, our first x? 0, right? Because they correlate. When we plug 0 in, we get 3, right? And when we plug 2 in, we get negative 1. So that's why 2 is x2 and negative 1 is y2. And same thing with when when 3 is equal to y1 and 0 is equal to x1. So, well, let's simplify this. What do we get? Well, we get negative 4 divided by 2, which is equal to negative 2. So even though it's kind of even though we can see that it's like a curved line right here, if we were to connect these 2 points right here, so here, let me make that easier to see. If we were to connect these 2 points, like at 2 is equal to negative 1, 2, negative 1, and 0, 3, and we were to make a straight line between them, we could say that that slope is equal to negative 2, which means that that's the average rate of change, negative 2. So to sum all this up, to find the average rate of change, you basically just plug your polynomial, say that y is equal to that polynomial, create a graph, find your 2 points, make a straight line, and find the slope of that straight line, and that's going to be your answer. Next, the fun stuff, adding, subtracting polynomials. So before I work through these, how about you guys try to solve it on your own, and if you need help, unpause the video and I'll show you how to do it. I just have a few examples. Let's do this one right here. So let's say we have 3x plus 6 plus 5x plus 4. So if you, in school, you learned about the commutative property, which basically says when you're adding, you don't need parentheses. You can basically put parentheses anywhere you want. So we can kind of take off the parentheses and we're left with this. Well, remember how I said about like terms? Here you're going to add the like terms. Obviously you can't add 3x plus 6 because they're not like terms, but we do have a few like terms here. We have 3x and 5x, and we have 6 and 4. So if we were to add these, 3x plus 5x is equal to 8x, and we have 6 plus 4 is equal to 10. So that's our final answer here. So 3x plus 6 plus 5x plus 4 simplifies to 8x plus 10. Now, one more example. So we're going to go over here to the 5x plus 10 plus x plus 6. So let's do this one a little faster. So remember I said before, you can take off the parentheses. So you're left with 5x plus 10 plus x plus 6, and add the like terms. So we have 5x and x are like terms because they're both x to the first power, right? And then we have 10 plus 6, they're like terms. So 5x plus x is equal to 6x, because remember, x is the same as 1x. So 5 plus 1 is 6, so 6x, right? Plus 10 plus 6 is 16. So we're left with 6x plus 16. So 5x plus 10 plus x plus 6 is equal to 6x plus 16. Okay, subtraction. Let's look at that. So, well, you might be thinking that it's very easy, but you must be careful. So let's start with this example over here. Well, before I start, pause the video and see if you guys can work this out yourself. So, what we got here, we have 7x plus 12 minus 4x plus 8. Well, you guys might be thinking, well, okay, what I can do is I can just take the parentheses off, right? You're like, yeah, it's easy. Parentheses off. You keep the negative sign, and boom, you work it out from there. Well, no, that's actually not what you're supposed to do. Remember, when you're working with parentheses, you actually have to distribute. So this is actually the same as multiplying the parentheses by -1, because you want to distribute the negative sign. Okay, so if we're distributing the negative sign, we get 7x plus 12 plus -4x plus -8, because remember, the negative sign is distributed. Okay, and from there we add up the like terms just like we do with addition, and we're left with 3x plus 4. Okay, see that? So 7x plus 12 minus 4x plus 8 is equal to 3x plus 4. Okay, let's move on to another example. This one's slightly more complex. So I always like to, instead of saying minus something, I always like to put it plus negative. So in this case, minus 3, I like to put it plus -3, so I don't get confused or lose the negative sign. So let's do that same thing with the -5. And now, remember, we can get rid of the parentheses of the first one. Remember, first, it's like multiplying with -1, so we must distribute the negative sign. So plus -5x plus 5. Okay, well, you're like, okay, well, if it's two negatives, why is it 5, right? But remember the rule that when you're multiplying two negative numbers, it's going to be equal to a positive number. So let me see if I can write that. We have negative times negative is equal to positive. Hope that helps you guys understand. So remember, negative times negative is positive. But if you guys are learning Algebra 2, you probably already know that. So let's get over here. We're adding like terms, right? So we're left with 3x plus -3 plus 5 is 2. Okay, so 8x plus, or minus 3 minus 5x minus 5 is equal to 3x plus 2. Look at that.